So got asked about a refresher for translations, and so those are the things that um, might look like this if you have some kind of function. Okay, so the letters inside the parentheses, the numbers inside the parentheses, those are all horizontal. So they move things left, right, or they stretch it sideways. Okay, and then the numbers on the outside are all vertical transformations. Okay, now we split these up into a couple of things, so let me make this a little bit more detailed. Uh, so inside the parentheses, this number, whatever it is, moves it left if greater than 0, and it moves right if less than 0. This is a horizontal compression. If it's less than 1, no, greater than 1, sorry. And a stretch, boy, if it's less than 1. Man, is that writing terrible. But it stretches the graph if it's less than 1, and it compresses the graph if it's greater than 1. Now, these numbers on the outside, that is a vertical stretch if that is greater than 1, and a compression if less than 1. And this number out here is a vertical shift, and it moves up if greater than 0, and down if less than 0. So let's just start off with a nice easy example. Let's say our function that we're kind of starting with, our base, is just a parabola, x squared. Okay. Now, let's say I would like to graph then this function x plus 1 squared. Now I can kind of see, that's based off of the basic power function x squared. Okay. And the plus 1 moves, we're going to move the graph left 1 spot. Okay, so every point on this graph just moves left 1 spot. So that comes over here. This point moves over here. This point moves over here. So just everything on the graph. And so we could see, if we do that, the graph of that function is going to look something like that. Now, if we then try to do something like x squared plus 1 minus 3, okay, I always do my horizontal translations first. Okay, then I do the vertical translations. So here we would move it left 1 and then down 3. Okay, so the final graph, we moved left 1, down 3, 1, 2, 3. So the vertex would be there. This point moves 1, now down 1, 2, 3. This point would move down 3 spots. 1, 2, 3. 1, 2, 3. And we could kind of see the graph. If I could draw a nice little parabola, it would look something like that. Right? So those are kind of your easy basic translations, just the left, right, up, and down. Inside the parentheses, things kind of behave a little bit backwards. Okay, positive numbers move left, negative numbers move to the right. The vertical ones behave like you would expect them to. Negatives move you down, positives move up, however many points, okay, however many spots. Now, the stretches and stuff like that, so let's stick with x squared because I can draw that. Yeah, you can see how well I can draw, right? So just for comparison's sakes, there's our x squared. Now, let's just say that I would like to graph two x squared. Now, if I want to graph 2x squared, then this 2 out in front means I'm going to double all of the y coordinates. Okay, we say it stretches by a factor of 2. Okay, so this point is 0, 0, and if I double the y coordinate, and that's all we're doing is we're doubling the y coordinate. Okay, so that's all that this means. Then it's still going to be at 0. So, boom, it's right there. Now, this point, 1, 1, that's going to move to 1, 2. Because we double the y-coordinate. This point here, which is 2, 4, is going to get translated and move to the point 2, 8. And then same thing on these sides. You know, we'll have the point negative 1, 1. That's going to move to the point negative 1, 2. And then we have the point negative 2, 4. That'll get shifted up to the point negative 2, 8. And you can see what happens is it makes the graph kind of taller and skinnier. And if that number is less than 1, you still multiply the y-coordinate by that to get your new y-coordinate, and it's just going to make it shorter and fatter. Now, if the horizontal stretches, a lot of people don't cover those because you can actually manipulate it a bit to turn it into a vertical stretch if you'd like. Okay, but let's say that we had this. Since that's inside the parentheses, that is a horizontal compression by a factor of 2. So that just means, what are we going to do? We're going to take the x coordinates and we're going to divide it by 2, okay? Because it's a compression. So if I wanted to do that, then let me erase this stuff out here because it's going to get really crowded. But I'm going to leave the red graph on there just as a comparison. Okay. So if I do that, then this point here gets moved to the 1/2. So 1, 1 gets shifted to the point 1/2, 1. Negative 1, 1 is going to shift to negative 1/2, 1. See, the x coordinates all get squeezed. And I accidentally deleted the original graph, didn't I? All right. And then the point 2, 4 is going to move into 1, 4. Okay. Of course, the x coordinate is going to wind up staying the same. So you can see we've made this graph a little bit skinnier. Okay. Which also kind of looks like a vertical stretch. You know, it visually. It's not, but it kind of visually looks that way. But what I was saying, we could algebraically manipulate that sucker because that is 4x squared, right? So what that means is that we could, instead of thinking about it as a horizontal compression, we could think about it as a vertical stretch by a factor of 4. Okay, um, we could quadruple all of the y coordinates and wind up with the same graph. And because that happens a lot, because you can always factor things out, stuff like that, uh, you'll get a vertical compression that gives you the same graph. So you'll see a lot of places skip that one, okay? Except for trig functions. That one becomes a little bit more important. All right, so what if we did, a combination of a couple of these things? Okay. So we could, if I wanted to graph f of x equals 1/3 x minus 2 squared plus 1. Okay. This would move it right 2. This number would move it up 1. And this compresses it by a factor of 1/3. Okay. So I would actually kind of, if I were sketching this, I would do it in 2 steps. So I'm going to start off with our basic x squared. Okay. And I think the first step I always do kind of left-right stuff, so I'm going to move right 2 units. So every point on the graph gets shifted right 2 units, and that takes care of my vertical one. And then I'm going to shift, okay, up 1 and by a factor of 1/3. Now you need to do these in a particular order, okay? Do the multiplication stuff first, then do the up and down, okay? So let me do it in 2 more steps. So everything is going to get, all the y coordinates are going to be multiplied by 1/3. So that puts this point here. The y coordinate is 0 times 1/3 is going to stay the same place. Just to write out this one, so that point 1, 1 gets moved to the point 1, 1/3. Okay, and so this one would be down at 4/3. That's 1 1/3. This one gets shifted down to 4/3. So that's going to be here. So you can see what happened. This thing kind of shrank, and it made it a fatter, shorter parabola. Then for the final step, I would move all of those points up 1 spot. Okay. So just because of the crowdedness, I'm going to erase this red one since I'm not using it anymore, but I'm going to leave the blue one for comparison. So we're going to move all of those points up 1 spot. And there's my graph of f of x. So I'm going to go ahead and get rid of this blue one so you can see where it started and where it ended up. Okay. So that's what all of those numbers do with the translations. I hope it helps a little bit. Be careful about the orders in which you do the translation. And if you need some more examples or more details, please let me know.